All right. Good morning, everyone, and welcome to the California, Nevada, or the March California, Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thank you for those that have joined us previously and those that may be joining us for the first time. My name is Amanda Sheffield, and I'm the Regional Drought Information Coordinator for NIDIS in California, Nevada, and I'm affiliated with the Cooperative Institute for Research and Environmental Sciences at CU Boulder. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and the recording will be available on drought.gov and on our YouTube channel later this week. And you should see in chat a welcome message that includes the link to the YouTube channel. We've got a great set of speakers this week covering current conditions as outlooks, as well as an update on California rainfall conditions. And I did want to set up first. Normally we do California and Nevada rangeland conditions, but we weren't able to get a speaker for Nevada at this time, but hopefully we'll be able to for next time. Before we get started, just quickly, for those that aren't as familiar with NIDIS, our mission is to improve the nation's capacity to proactively manage drought-related risk by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We work to improve our understanding of how and why drought affects society, the economy, and the environment, and to improve accessibility, dissemination, and the use of early warning information for drought risk management. We do this for working through drought early warning systems, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make climate and drought science accessible and useful for decision making. A lot of these activities that fall in the drought early warning system are in these different areas of observation monitoring, planning and preparedness activities, prediction and forecasting, interdisciplinary research, as well as communication and outreach, as webinars like this. One thing I want to mention real quick, if you are in Southern California, I mentioned this last time, but we are doing a pilot to provide better sector-specific and region-specific drought early warning information. So this, for example, we've been working on Southern California agriculture, public health, and water utility sectors. And if you're interested in participating and doing those, we do these on a monthly basis. The next one is next week. Feel free to either email me or go to this QR code for some more information. But if you are in Southern California in those sectors and want to sort of take this webinar, like the information you get from this webinar, and take it another step, we're happy to have you, and feel free to reach out. Last thing I want to mention before we get started, realize you'll see in the update the current drought conditions. And with that, I wanted to mention a couple different ways for you to report drought impacts. One of them are from condition monitoring observation reports. You can see the website there. And I did want to mention that it's an easy way for you to report your impacts, more than just crops. It could be anything from air quality, dust, lots of different social impacts, as well as you can submit photos to that reporting database as well to sort of show people what you're seeing on the ground there. And that information is used often for the U.S. Drought Monitor, state and local level at the state, and also at the state and local level to understand what's happening on the ground with drought. So with that, I'll go ahead and jump into our great agenda with our first speaker, who's Dan McFoy from the Western Regional Climate Center, and he's going to be providing the drought and climate update. And Dan, I'll pass it over to you.
Okay, well, great. Thank you, Amanda. Yeah, thank you so much for having me here today. I'm going to provide an update on what's been going on over the last few months in terms of the drought and climate in California and Nevada. This cover photo here is just from about 10 days ago that I took in the Mount Rose Meadows near Lake Tahoe, where it very much was still winter. You can see the summertime restrooms just about buried in snow there, and we'll talk a bit about where the snowpack stands as one of the elements we cover today. I wanted to start out by focusing on the winter climate, December through February. And for our region, especially California, but also a lot of Nevada, the winter's a very critical season in terms of getting most of the precipitation and, of course, also building the snowpack, which is critical for our water supply and one of the key drivers of droughts in the region. And so these two graphics here are from the WRCC Westwide Drought Tracker. On the left, we have the winter total precipitation percentiles, and on the right, we have the mean temperature percentiles. So on the left, with precipitation, the browns are below normal precipitation, and then the greens are above normal or wetter than normal. And we see a dipole in the precipitation that developed this winter. with much drier conditions in the southern part of the region and also in eastern southeast Nevada, and then actually much above normal precipitation in the far northern part of the region. But I wanted to point out in terms of drought, it was record dry winter for portions of southeast Nevada, and in the bottom 10% dry winters for several areas in Southern California as well. So very dry down south. And most of the map on the right is red, indicating that temperatures were generally above normal throughout the winter. And a lot of those areas in that middle shading of orange is in the top 10% warmest of all winters on record, going all the way back to 1895. And so this has, of course, implications for developing snowpack and snow level, and also drying areas that don't have snow on the ground as well. So warm and dry for the south is kind of one of the key messages to think about going into the spring and summer. And I did want to show this broken down month by month because there were some interesting things that stood out. So these are the same types of graphics. On the top row, we have precipitation. And on the bottom row, we have the temperature percentiles. And these are broken out by month. So December on the left, then January, then February. And a couple key things that stand out here. December had that dipole, again, wet in the north, dry in the south. January stood out as an extremely dry month. It was very dry across the entire region. Even the north was very dry. Northeast Nevada, the Sierra Nevada was very dry. And when you miss one of these big 3 months, particularly for snowfall in the Sierra Nevada, it's very hard to make those deficits back up. And so it was really big to not have that precipitation in January. And then February improved quite a bit for precipitation across the region, especially in the Sierra Nevada and Southern California. And then temperatures were variable from month to month, but again, mostly warm. December was extremely warm. And then what I've highlighted there is that oval kind of approximating the Sierra Nevada region, which was warm for a lot of the winter there. And so again, that's going to have impacts on accumulating snow and lower elevation snowpack. And so this graphic here is from our WRCC state climate trackers, and this is showing a time series of the winter mean temperature for that Sierra Nevada region, approximately where I highlighted in that previous graphic. This is going from 1895 through this past winter using PRISM gridded climate data. And so this year turned out to be the fourth warmest winter on record for the Sierra Nevada. And it certainly did have some impacts on the lower elevation snowpack, and I'll talk about that a little when we show some snowpack graphics. Still remarkable how warm the 2014 and 2015 winters were there. 2015 was the warmest on record. But again, so this year was very warm in the Sierra Nevada relative to the recent past, but also relative to the past 100 plus years going back to 1895. So if we take a look now, what's happened in March so far, these two maps are from Climate Engine using GridMet gridded climate data, showing the precipitation on the left and temperature on the right from March 1st through the 20th. And on the left, we have the percent of average precipitation. So we see a lot of greens on there, mostly above average precipitation for the region. The darker greens are areas that are showing 130 to over 200% of average precipitation for that period. There are some isolated areas with below normal precipitation, but the areas that really needed it were, Southern California, Southern Nevada. Southern California did get a good amount of precip, and the Sierra Nevada, especially the central and the southern Sierra along the west slope, got a lot of precipitation in March, which was good. So the other good thing on the right that we're looking at are the temperature anomalies. And so that entire map is basically blue now, which is good, indicating below normal temperatures so far for March. That's definitely changing over the next week or so, but the month may end up still near to below average when we look at the entire month. So primarily a wetter and cooler March for most of the region, which is a good thing this time of year. And next we want to move into the snowpack, which is critical for our water supply and drought, as I mentioned. And so this is a graphic from the NRCS, the SNOTEL network, which operates the mountain snow pillows across um, the western United States. And so this is showing the basin average snow water equivalent, or the amount of water in the snowpack as of the end of the day on March 22nd, so as of yesterday. The blues and greens are above normal snowpack or near normal snowpack, and then the yellows are below normal. So what's good to see here is that most of the map is greens and blues. We see the northern part of the region with well above normal snowpack, 150% of normal or greater. And as you go further south, those numbers get lower. The southern Sierra region is showing 88% of normal. But I also wanted to mention that we're nearing that typical peak snow water equivalent, particularly at the higher elevations, which occurs usually around April 1st or a bit after that. We've even surpassed that at lower elevations, past that peak snow water equivalent. And so we're moving in the next few weeks into the snowmelt season, and so it's critical to get as close to this average as we can. But really, in the Sierra Nevada, we've been chasing that normal or near average snowpack for much of the season, as we see some of those areas are just below 100% in the Sierra. If we look at the various regions now based on the California DWR snow pillows, which is a different network than SNOWTEL, but measures the same kind of information. So on the top left, we have the northern region in California, on the top right, the central region, and on the bottom left, the southern region. And I've put a few different numbers up there. So the black trace is this year, the gray trace is last year, and then the blue shading is the average. And so if we start in the north, we can see that 116% of average for the date, but also 114% of the April 1st average. So that's very good, already surpassing that peak sweep. As we move further south, we see in the central region at 92% of average and 89% of that April 1, and the same numbers in the southern region, 92% of normal for the date and 89% for April 1st. This is also very similar to the snowpack for this time last year, at least in the middle and higher elevations, a bit lower, less snowpack at lower elevations than this time last year. And these are similar graphics now, but from the NRCS SNOWTEL network for the eastern Sierra Nevada on the top left and the Humboldt Basin in northern Nevada on the bottom right. The eastern Sierra is lagging a little bit at 90%, 7% of normal for the date, but only 90% of the peak SWE. And so this red circle is when the median peak usually occurs. And you see we're still trying to catch up to that. And the bottom right is the Humboldt, which is having quite a big snow year this year. That orange line is last year also, so that's the second big year in a row for the Humboldt. They're currently at 142% of normal for the date and 116% of peak, so they've already surpassed the peak. So again, we see this gradient with, as you go further north in the region, the snowpack is much better. I did want to highlight, so these are a couple of maps from Climate Engine showing SNOWDAS, which is a model that models the snow water equivalent. On the left is from late March of 2024, and on the right is from this year, and it's the percent of average snow water equivalent. What I really wanted to highlight is that at the lower elevations, middle and lower elevations of the Sierra Nevada, you can really see it around the Lake Tahoe area, near the shoreline areas, a lot more browns this time than there was last year. So there's a lot less snow at lower elevations. There were warm storms in December and also in February that brought rain at lower elevations. And so this could have potential impacts on the timing and the volume of the total seasonal runoff. And I briefly wanted to touch on this project that I'm working on that was funded by the U.S. Bureau of Reclamation to incorporate snow temperature measurements into the Federal Snow Survey. The snow temperatures can tell you a lot about when the snowpack is ready to melt in the spring, and also when it could melt in terms of flooding in the middle of the winter. Dr. Ann Hegley from DRI is leading this project. But so this is a recent measurement that they took last week from March 19th. The snow pit there is 112 inches of depth, and so this is just below 7,000 feet elevation on Donner Pass. And so what they found there on that measurement was that the snowpack temperature on average of the whole column was just below freezing, minus 0.2 Celsius, and there was a little bit of cold content in there. And so what that means is that most of that snowpack is ready to melt, except for the very top layer of that new snow. So as we get into the warming spring period, there could be a rapid transition snow melt, giving that column is ready to melt, particularly at that elevation around 65 to 7,000 feet. And I also wanted to note that we are shifting right now into a looks to be somewhat brief, but very warm and dry period over the next several days. These are the minimum temperatures from this morning, and we can see that a lot of the mountain areas did not get to below freezing, and there are temperature inversions in place. And so some of the higher elevations were in the mid 30s or even close to 40 degrees Fahrenheit. And so we should see a 2 to 3 day period of snowmelt occurring over the next couple of days with this spring heat wave that we're entering right now. The soil moisture is shown on the left, the soil moisture percentiles from the NASA product there, and it's showing kind of a mixed bag, but generally near to above normal soil moisture right now in the Sierra Nevada and Northern California, and then some areas of below normal soil moisture in Southern California and parts of Nevada. And on the right, we have the traces for the Eastern Sierra Nevada from the SNOTEL network, and on the bottom, the Upper Humboldt. Both of those areas are below normal soil moisture for this time. We do see those increase as we get into the snow melt season over the next month or two. So we'll have to see how that unfolds. And this next slide is showing the observed water year-to-date runoff across the region from the California-Nevada River Forecast Center, showing much above normal runoff so far for the northern part of California and a few areas in northern Nevada, but much below normal seasonal runoff in Southern California, and then also below runoff in northeast Nevada there, where right now the snowpack is above normal. So that's a good thing to see with the snowpack at least. So in terms of reservoir storage and surface water supply, on the left, we have all the reservoirs, main reservoirs from California, showing the percent of averages and the percent of capacities. And the take-home message here is that nearly all of these reservoirs in California are showing above average for this time of year, which is a good thing. We still have a buffer in the surface water supply from the really big winter 2 years ago and the near normal winter we had last year. And then on the right, we have the reservoir storage for the major Nevada reservoirs, which are also all in pretty good shape, mostly above average, except for the ones from in southern Nevada that are being fed by the Colorado River Basin, which are still at critically low levels, 61 and 59% of normal for Lake Powell and Lake Mead, respectively. And so finally, just this drought snapshot from the U.S. Drought Monitor. I think I'm running out of time here, but on the left here, this is from the map that was released last week. So we do see areas of drought all throughout Southern California and a lot of the southern 2/3 of Nevada, with a few areas of extreme and exceptional drought in the far southeast part of the region. And most of that has developed since the beginning of this water year due to the warm and dry conditions. So I'm just going to stop there, as I think I've gone over time, and see if there's any room for questions. Thanks.
Hi, Dan. With that, we're just going to keep plugging along, and we'll do questions on the next towards the end when we get if there's a few more for all the speakers. With that, we're going to shift over to my screen real quick. Nathan Patrick, who's a hydrologist with California Nevada River Forecast Center, and he's going to be providing the drought and climate outlook from the River Forecast Center perspective.
All right, thank you. So just start off here, the background image is the true color imagery from the satellite captured on March 8th, depicting the snowpack extent prior to the recent storms. This was the last clear day, or mostly clear day, across the entire California-Nevada domain. There's some clouds in northeast Nevada, so some of that's not snow, and then there's some haze over far northern California along with some cirrus clouds. But as I'll show, our mid-March cold systems added to the snowpack depicted here. Particularly, it provided some lower elevation snowpack, which will probably burn off a little bit this week. So today I'm going to provide an overview of the CNRC's outlook for the April through July seasonal river forecasts, while also briefly covering the climate prediction season outlooks. So go ahead and advance the next slide. All right, I've borrowed this slide directly from the Climate Prediction Center. Recent observations suggest we are currently transitioning from weak La Niña conditions to neutral conditions. The Climate Prediction Center ENSO probabilities favor neutral conditions through summer. Typically, the ENSO predictions at this time made in the spring tend to be the least reliable for upcoming seasons compared to predictions at other times of the year. And if you want to know more, the website there has a really long and good description and discussion if you want more information. Go ahead and advance the next slide, please. All right, the April to June CPC temperature outlook suggests above normal temperatures across much of the region with increasing probabilities as you head east. One important note, more saturated colors don't indicate varying levels of magnitude, so darker oranges don't indicate much warmer. They merely indicate that the probability of warmer temperatures increases. Looking at the map, above normal temperatures, if they materialize, would help dry out vegetation quicker, melt higher elevation snow quicker, and perhaps contribute to increased fuels, which may support a longer duration fire season. Go ahead and advance the slide, please. Below normal precipitation is favored for the April through June time period. From a climatology perspective, conditions do get drier from now through summer. Somewhat counterintuitively, springtime precipitation falling as rain can sometimes be a negative. First, it can melt snowpack more quickly with warm, humid storms in the mountains, which isn't desirable from a water supply perspective. The preference would be for the snowpack to act as a natural reservoir and melt slowly. Second, for our region, substantial springtime precipitation can increase smaller vegetation growth, which will later dry out and produce additional fuel for fires. It's a balancing issue of not wanting too much or too little precipitation over this time period. Go ahead and advance the slide, please. Drought can be measured in a variety of ways, the most common being precipitation and soil moisture, which drought.gov and the CPC outlooks focus on. Based on these criteria for the California-Nevada 3-month outlook, drought conditions are expanding and intensifying over large portions of Southern California and Nevada. Go ahead and advance the slide, please. Okay, so in order for the CNRC to produce stream flow forecasts and water supply projections, we need to use a variety of inputs. One of those is precipitation. On the left is the quality control precipitation grid that we produce internally each day, some from the start of the water year on October 1st and compared to normal through Saturday. This would be the precipitation input we use to keep track of our soil states and the building of our snowpack volume. On the right is a similar depiction, but shows the mean aerial average for the Huck 8 basin units, which would then get broken down further into the basins that we explicitly model. It is important to note that when comparing with other precipitation products, such as what Dan showed from other sources, we may not use the same period of record and/or mean versus median criteria. So for drier areas, this can skew precipitation representation. In addition, different gauges and QC processes could be used. So go ahead and advance the slide, please. All right, on the right is a depiction of what snow water equivalent looked like last year. Oh, sorry, slides must be out of order here. Okay, so looking here, this is the station point data suite that we have. On the left is the percentage of average, and over on the right is the snow water equivalent 14-day change. This would be the absolute SWE amounts or snow that's been added to our snowpack over the last 14 days. Go ahead and advance to the next slide, please. All right, so At the CNRC, we tend to model our SWE, and so one of the things that we need to do here is divide things up into basically lower zone and upper and middle zone. So on the left-hand side is you have a composite image of all of those zones, and this is explicitly how we would model our zones. So as you can see, for the upper and middle zones, overall, we are modeling above normal precipitation or snowpack for those regions. But even in the lower zones in the upper right-hand corner, you can sort of see where some locations do have below normal snowpack, and that's primarily due to the fact that this could be just lower elevation. And once again, these could be drier areas in general, such as the Pitt River in Northeast California, and you don't typically will get a large snowpack accumulation there. So any kind of quite adjustment may impact that.
Nate,
All right, go.
did I accidentally skip your sweet slide? Do you want me to go back?
No, it's okay.
Okay.
You can go ahead and advance the slide. And let's go ahead and skip over this as well. Dan already covered a lot of this. All right, so this is a web page from our website that you can go to there. The URL is listed there. So in addition to providing river forecasts at the official forecast locations, the CNRC provides probabilistic forecasts at many more locations. Products include water supply forecasts that can help inform out to 365 days based on near-term weather forecasts as well as climatology. I don't have time to show all of these locations, but you're more than welcome to browse them on your own time. But I will highlight two of the blue dots, which you can sort of see there in Central California. These are water supply indices, which we can use to assess how, I guess, stream flow would be for a large portion of the regions. And so one of them aggregates the Sacramento River drainage, which includes the Northern Sierra, and the second one aggregates the San Joaquin River drainage and includes portions of the Central and Southern Sierra. So go ahead and go to the next slide. All right, so the first blue dot, this trend image shows the ensemble-based River Forecast Center's unimpaired flow forecast for the April through July on the Sacramento River system, which basically aggregates the Shasta, Feather, Yuba, and American systems. You can think of this as the expected natural flow if there was no human modification of the waterways. The CNRC forecast incorporates current conditions, current weather forecasts, and then climatology as inputs. It does not incorporate hydrologic uncertainty. When I created this plot on Saturday, as of Saturday, our median seasonal forecast includes 6.5 million acre feet, which is 137% of the 1980 to 2023 median. Different color banding indicates probabilities of exceeding a certain seasonal volume. So the most likely scenario would be represented by the purple shading. The trend line shown with the darkish purple color shows how the forecast has changed as we moved through this fall and winter. The light gray trace indicates daily flow observations. Today's forecast is beginning to incorporate wetter weather heading into next week and the start of April. And so the current forecast, if I look over here and get the current numbers, it's up slightly. So today we are actually projecting a median runoff of 6.8 million acre feet, which is 143% of the median. Once we enter April, any observed runoff will start to be aggregated and accumulated by drawing a pink curve line starting near the bottom at the April 1st x-axis label location. And the runoff progression can then be compared with the dotted blue trace and the dotted green median trace within the April through July black runoff box. So go ahead and go to the next slide, please. All right, this bar chart provides the seasonal April through July flow for various years along the Sacramento River system. As you can see, boom and bust years and interannual variability can be expected, and this year's forecast is shown by the red bar in comparison to previous years. And then the dotted line that you see there provides a running 3-year average trend line. So you can just sort of see how we have this interannual variability where we go up and down. And right now we're looking at, like I said, being just over the mean is the projection. So go ahead and advance to the next slide. Okay, showing here, this plot shows total unimpaired flow on the Sacramento River system over a 5-year period covering water years 2021 through water year 2025. The pink portions represent accumulated observed flow over the last 4 water years, with this year's remaining water year forecast shown by the colored dots on the right. Each black vertical line separates each water year. The dotted curvy blue line indicates what normal 5-year water volume accumulation should be. And if you were to add up this water year's forecasted flow with the previous 4 years, the aggregated 5-year flow is projected to be 91% of the 5-year mean. So along the Sacramento system, the water year deficits that we had at the start of the decade in water year 21 and 22 more or less has narrowed over the last 3 wetter years. Go ahead and advance to the next slide. Okay, as of Saturday, here is a similar seasonal trend forecast for the San Joaquin system. The forecast is 2.9 million acre feet for the April through July time period, or 98% of the 1980 to 2023 median. Today's morning forecast updated that with the upcoming expected wet weather, and the median forecast is now 3.2 million acre feet, or 108% of the median. Looking at the median trace forecast shown by the purple line, you can see the drop in the forecasted volume in the second half of January when it was dry. But things quickly turned around and got wetter in February, and the median forecast once again trended upward along the green median level. So with good news is that with wetter conditions looking like at least the first week of April, hopefully the snowpack peak will be pushed back a little bit later, and that's actually maybe have a little bit later of a snowpack peak, which should help keep these trends up slightly higher. Let's go ahead and go to the next slide. Okay, so here is the San Joaquin's April through July historical flow comparison with this year's forecast shown by the red bar. And once again, you can sort of see that it's looking like it will get close to the median level over the roughly 40-year period. Okay, go to the next slide, please. All right, similar to the Sacramento system, adding up the San Joaquin water supply index for this water year's forecasted flow with the previous 4 years, the 5-year flow is 96% of the 5-year mean. You can obviously see there in the middle of the plot how drastic the water year 2023 was, which produced the substantial uptick in the pink curve. Without the near record water year 2023, the early deficit gap from 21 and 22 would not have been made up. And one other thing to keep in mind when you're comparing between the Sacramento and the San Joaquin system is that the Sacramento River system typically has about 2.5 to 3 times the volume of the San Joaquin system. Go ahead and go to the next slide. All right, so zooming out, this is once again looking at our entire domain. Depicted here are unimpaired runoff forecasts for the water year on the left and the April through July seasonal runoff on the right. Greenish to bluish colors are indicating near normal to above normal flow is predicted for most of Northern California. Elsewhere, full natural flow is expected to be below normal, with portions of the Central Coast and Southern California being well below 50% of normal. Kind of a mixed signal out there in the Humboldt. Part of that is due to the fact that maybe our precipitation might be a little bit different than what was shown by Dan. Part of that is we think that things should be fairly good runoff in the immediate Elko areas near the Ruby Mountains. But then again, once again, as we get further downstream, there was less snowpack, at least in terms of our models. And our models might be slightly off with some of the accumulation. So hopefully, we will have an efficient runoff, and things will hopefully be a little bit better than what we're depicting here for Northeast Nevada. Go ahead and go to the next slide. Okay, so looking at the forecasted peak flow dates, I would expect that with our cooler weather, once again, this was produced on Saturday, that some of these dates may extend back a little bit further, particularly for the high elevation locations. So those would be the dates that would be probably highlighted by both the May dates as well as the June dates. So if we can build a little bit snowpack, they may trend back in the other direction. That being said, if according to the CPC temperature projections, if we do get a warm April through June, then that kind of will counterbalance that and maybe move things up a little bit sooner than what's being shown here. But I think with the wet weather that we're anticipating for next week, that even some of these early peak runoffs being shown there in the first week of April, I think that's probably a little bit optimistic, and probably peak runoff will be pushed back a little bit compared to what we're showing here. So go ahead and go to the next slide. And I think this is just going to be my slide here, just showing that at least across the country as a whole, we're not expecting any real widespread U.S. spring flooding. And so with that, I will conclude.
Great, thanks, Nick. There's a quick question that I'll ask why I'm changing presenters. Do you have a list of the stream gauges that represent natural or unimpaired flow that I could potentially use for my research?
Maybe have that question directed to me offline, and then I'll get back to that.
Yep, I can do that. Thank you.
All right, thanks.
I think you might be muted if you're trying to speak. We can see your slides though.
Yes, thank you so much. Okay, I'll try that again. Good morning, everyone. My name is Leslie Roach, and I am representing Cooperative Extension for California. And I'm going to talk a little bit about how this year's precipitation has impacted rangeland forage conditions so far for California, and how it may continue to impact going into the spring and summer. So just as a little bit of context for California's rangelands, they are incredibly biologically diverse, ranging from arid deserts and shrublands to more mesic grasslands and woodlands, and even include some of our forested lands up in the mountainous areas. And so we span quite a range of climatic zones, from desert to semi-arid to Mediterranean. For California, this means that this diversity supports what we call transhuman ranching, where livestock are moved between pasture-based forage resources in a somewhat seasonal cycle, typically from lowlands in the winter period, so those annual grasslands where they are now, and then they move up into the highlands, mountain meadows, or perennial grasslands, for example, as we get into summer. And for these lower elevation, grasslands, the majority of the base ranches are in those areas, as well as the foothills. So focusing on California's annual rangelands, they are mostly privately owned. They are a major forage base, and so they're integral to that yearly annual grazing calendar, that forage clock, and they provide a critical economic foundation. And this time of year is what we're really looking at in terms of seasonal progression, as these annual rangelands. The annual rangeland productivity in particular can be particularly challenging. Productivity is extremely variable, in part because the plant community's phenology is dynamically linked to our seasonal weather patterns. And so the key challenge is that we need both optimum temperature and moisture conditions together for plant growth, and typically they're out of sync with each other for our annual grassland system. And so kind of how that looks, this chart is just kind of just a stylized progression of growth rate over the growing season, over the entire year. And if all goes well, typically the annual rangeland growing season is initialized with those fall rains anywhere from September through December. And then as we move into that December through February period, into that winter period, plant growth typically slows because we have those typically lower air temperatures and lower solar radiation. As we get into late winter and early spring, kind of where we are now, through February and April, we enter that rapid growth phase as air temperature increases and solar radiation intensifies. And then in mid to late spring, so around April through June, after that rapid growth stage, we see plant production reaches peak biomass, especially once the root zone moisture is depleted. So what that results in is that we have extremely high spatial temporal variability in forage production. And this is due both to the characteristic climatic and biophysical diversity that I just showed, and how that's also dynamically linked to the phenology of the annual system. And this is just an example of what that can look like on the ground. Forage production can vary by as much as 3 times or greater, both interannually, so within a year at a given location, and even within a given year at different locations. And of course, this variability is further increasing as we see increasing climate variability, increasingly large year-to-year fluctuations, and instability of the forage supply. So based on some of the work that we've been doing in collaboration with Extension, as well as the Jing Lab here at UC Davis, we've been looking at integrating remote sensing tools with on-ranch monitoring. And through that, we've been able to confirm that there's a number of factors that drive this variability in long-term forage production, but the dominant ones are the precipitation amount, so total amount, and timing, being those dominant drivers. Particularly November precipitation, so that's that critical germination period, and April, that's when we typically see rapid growth in many areas. These are particularly strongly influence forage production. Now, of course, the importance of these drivers vary by region. There are other drivers that play more critical roles in other areas. Precipitation plays a more important role in drier areas, not surprisingly, where we see variables like energy and temperature playing larger roles in wetter areas. So this is all to say that growing grass, particularly in the annual grasslands of California, is much more complicated than just looking at water year totals. That's just kind of the take-home message from all of that. So what is this year looking like for California rangeland conditions? This is just a kind of look back at what the last 2 years have looked like. We've seen, for this time of year, some steady improvements. I don't have it here, but actually March 2022, there was widespread severe to extreme conditions across the state. So we've been a little bit better the last couple of years, and we've already seen this today. But as we heard, Northern California is, again, at the designation of none, with worsening conditions for the southern part of the state. And I will point out, and I think we saw a couple images of this that maybe Dan showed, was that early on, particularly in January, I believe, as well as November, Northern California was abnormally dry during that earlier part of the season, which can have implications for total forage production at peak. So I'm just going to give a snapshot of some of the locations where we have extension folks that have sent in reports from the ground to just kind of match this with what's being reported on a national scale. So starting with Northern California, it's still, as always, March is a bit early in the season to say much about Northern California. Siskiyou County has had lots of rain and snow. We have reports of grasses greening up since the latest storm. They've also had springs that were dry during, I believe, from about 2017 through 2022, which was pretty critical, but they have now been flowing pretty consistently. So that's good news for them. This is about their second above average water year, but they do still have curtailment orders that have been in place since the 2021 drought proclamation. So there's expected impacts there. For the North Coast, a bit of a qualitative assessment. It's wet, really, really wet. So this is a typical winter challenge for the North Coast of, they have these super saturated soils, which could limit access to lower pasture lands. On the other side of the valley, we also have reports from Plumas and Sierra counties that they've also had some flooding, so also pretty wet for them. As we move to Sacramento Valley, Glenn, Colusa, Tehama counties are all reporting excellent forage, reservoir, lake, and creek conditions for this time of year. Butte County has average forage conditions for early season. And Yolo County also reporting near average conditions, and they've had some favorable timing of rains. Moving to the Sierra foothills in the northern Sierra, forage production is on track. We have a long-term monitoring site at a local UC Research and Extension Center, and they're reporting that forage production is right at historical average. For the central Sierra, also reporting average conditions currently with streams running and ponds full. For the Central Coast, a little bit further down south, things are a little tougher. Forage growth is behind schedule. They're reporting that forage is only about a few inches tall, maybe 1 to 3 inches tall. The recent March rain has provided some help, but they need about 3 to 4 inches more of rain to provide adequate feed. Local extension there estimates that if they don't get any more rain, they're expecting about a 40 to 60% loss in total forage production. And that's based on data they've been collecting for the last 20 years. And I just wanted to note also in Monterey County, it's currently designated as none for drought conditions, but local extension folks report that it's probably more abnormally dry, particularly for that southern half. Monterey County is only about 65% of total rainfall right now. Northern half is typically wetter, so they expect forage production to be adequate later on, but the southern part, they are looking at shorter forage conditions, and so maybe more abnormally dry, like the southern San Luis Obispo County. And then in the southern desert, the current U.S. drought monitor designations match those on-the-ground conditions of that, severe to extreme drought conditions. They've had some rain recently, but overall, it's been a fairly dry winter, especially in Imperial County. They've had some trace amounts recently, but they're still dealing with large long-term deficits. So just overall, Northern California rangeland conditions are, near or at normal, but folks are looking forward to some of those rains, particularly in April. For rangelands, drought is really always looming. We are looking at some potential above average temperatures this week, we just heard. And so that will increase evaporative demand and really could create kind of these thirstier rangelands. And that could mean that even average rains won't go as far. For Southern California, of course, they're struggling with conditions, current conditions, and they're continuing to deteriorate, especially if they don't get any more precipitation. So I just want to thank you all of our local contributors across California that contributed to this report.
Thanks so much, Leslie. And obviously with folks I was mentioning, hearing some of these impacts are on the ground, and so I always enjoy your presentations, one to hear sort of what's been going on, what's growing and what's not growing and all these things. With that, I'm going to pass it on to our last speaker, Steve Ostoya, who is the director for the California Climate Hub. And I'm going to present his slides, so just 1 second.
Great. Thanks, Amanda. Can you hear me okay?
Yeah, you're great.
Yeah, thanks. I agree. I always appreciate Leslie's talks. It's like taking a drive trip around the state of California with her, but in about 7 minutes. So it's really informative and neat to see how things are changing and shaping up throughout the state. So just as a reminder, the USDA California Climate Hub is functionally an applied climate science and solutions program where we work with our partners, including individuals like Leslie, to develop and deliver science-based region-specific information and technologies that allow people to make informed decision-making in the face of a changing climate. Next slide, please. Thanks. So I'm just going to give a highlight of a couple of things that we have available for folks to use that are out and freely available on our website. One for agriculture, and then one for forestry, and then I'll note a workshop that we have coming up this summer. So the first thing I'd like to share is it's a compendium of resources called Cal Agroclimate, and this is functionally a decision support system where we have high resolution gridded weather data and forecast information. And we've used this to make a number of tools, including a heat advisory that you can see there, a frost advisory, crop phenology, functionally growing degree days, and a couple of other tools that are more recent additions to CalAgroClimate that allow end users, this could be anyone from crop consultants to technical service providers to even farmers or ranchers, that make better decisions about um, current conditions and potential future conditions that are variety and crop specific. And of course, as I mentioned, are spatially explicit. So it's very useful. You can simply Google CalAgroClimate and it will pop right up as the first hit. This was done in partnership with a colleague of ours named Tapan Patak at UC Merced, who's, like Leslie, a cooperative extension professor, but in his case, it's in climate adaptation science. Next slide, please. I just want to point out too that we have various resources also for forest management or forest applications. Just noting a couple here on the screen. Also, these are again available on our website. We have two workbooks on the left of your screen, forest management workbooks that can be used either as standalone resources, or we can use them as part of structured workshops, helping people manage forests in light of changing conditions. One of these is focused on for non-federal lands, kind of the one in the back. You can see it's a forest management handbook for small parcel forest landowners across the Sierra Nevada and Southern Cascade Range. Again, freely available on our website. And the second in the front there is functionally a menu of different adaptation strategies and approaches for all California forested ecosystems. That's an all lands application. Another resource there that we've used to work groups through functionally what could be almost like a climate action plan, if you will, for their individual forest situation or set of objectives. And then on the other side of the screen, I just want to point out that many of you may be engaged in this, but there are a lot of different resources that have been put together to help groups or entities manage reforestation. And we've been asked in partnership with CAL FIRE and also Cooperative Extension just to pull all of these things together, and we've put them onto our web page for the time being, but we're soon going to be releasing this is a standalone website, which will functionally be like a reforestation dashboard. But right now, we're just calling it the California California Reforestation Resources page. That was a bit of a tongue twister for me. And as you can see, we've broken all of the various things that we have out in the world for California reforestation into several groupings: decision support tools, research publications, different frameworks or manuals, etc. And that's just another way to, in a way, we wanted to have a one-stop shop, if you will, so folks could find these things really easy in a structured way, depending on what they were needing to do and where they were in the state. Next slide, please. Next, can you hit the next slide? Yeah, thanks, Amanda. So this is the last slide. I just want to point out both Leslie and I are part of a large effort that was funded by the National Institute of Food and Agriculture to support technical assistance providers across agriculture, both production, agriculture, and also for rangeland applications, of which Leslie's the lead on. But we have several workshops. Actually, we have two, not several, two workshops planned this year. This is the first that have just come out, so I wanted to share that with y'all. This will be a workshop that's titled Managing Agriculture Under Climate and Weather Extremes. It's designed to be for technical assistance providers in the Central Valley. It's going to be in Merced, California on June 18th, and it is free. And if you want more information, please go ahead and take your smartphones out and scan that QR code, and you'll be able to get more information on this and also register. So that's a nice resource that, again, is a project that both Leslie and I have been a part of with the individual I mentioned before, Tapan, down at UC Merced. And there's one final closing slide, but that's all I have, Amanda. Thank you for the opportunity.
Great. Thanks, Steve. At this time, I'm going to swap over to like the opening regular slides, but if anyone has any questions, feel free to pop them into the questions box. We've got a few minutes. And I'll open that, but I'll go ahead and say a few things while we wrap up here. Well, thank you all for joining, and thank you guys for your great presentations and your great speakers. I'll mention again that the recording of this webinar will be available on drought.gov in the NIDIS YouTube channel later this week. Our next webinar is scheduled for Monday, June 2nd. Typically, the next webinar would be in May, but because the auto schedule landed on Memorial Day, we're moving it out to Monday, June 2nd. And you can also find any, I'll have all these slides and all these presentations. So if you have any questions following up after the webinar, please feel free to reach out for me, or my email's on the slide, as well as all the different NIDIS and NOAA drought websites and things like that where you can find us. I don't see any other further. Oh wait, here's one. Oh, someone just asked, I think, basically for your QR code, Steve. So maybe we can get that information and send that out afterwards with my post slides or something like that, or I'll reach out to this person individually. But that was the only question I see so far. With that, I guess I'll give it a second here. But if not, we can wrap up a little bit early. And if you do come up with any more questions, please feel free to come find me and send me an email, and we'll connect the dots. Thanks, everyone, and I hope you have a great Monday.